Let us look at some of the problems that were set in the year 2021 by the South African Mathematics Foundation, specifically the SAMO, South African Maths Olympiad, round 2 of the seniors in 2021. All right, so we go straight to the first problem, which reads as follows: a scale with 2 pans will balance if 8 identical cakes were put in one pan and 6 cakes and 0.125 kgs of flour in the other pan. What is the mass of the 16 cakes in kgs? Well, if these two are exactly the same, it means that you can remove these 6 from here and remove from the 6 from here, and we will have that 125 0.125 kgs is the weight of two cakes. All right, you want to know what the weight of 16 cakes is? Therefore, the weight of 16 cakes, this is 8 times 2, so it will be 8 times 0.125 is 1/8. 0.125 is 1/8 of a kilogram. So therefore, the answer is 8 times 1/8 is 1 kilogram. Okay, so that's the first one. Usually the first few questions are warm-up questions. So this is the solution that I've got, and you can see it's the same. I usually have the solution typed up just as a double check. Okay, let's now get on to the second problem. Second problem says the 4 rectangular fabric strips of length 10 centimeters and 1 centimeter are put flat on a table. All right, you can see how they are laid. Each one is 10 centimeters by 1 centimeter. So if you have a single one, its dimensions are 10 by 1. Right. The question is, what is the area of the table in square centimeters that is covered? Each one covers 10 square centimeters, 10 times 1. So 4 would cover 40. Square centimeters. All right, but just observe that some of these things are counted twice. Like, for instance, if you look at this part here, you got one overlapping the other. So you have, this is counted twice. 4 times 10 is 40. So the same thing happens at these other places. But there are only 4 other places where it's counted twice. So we got this count of 40 gives you 4 more than what we require. Right? So the actual area that is covered is 40 minus 4. Centimeters squared. Sometimes we write square centimeters like that. Okay. Let's get on to the next problem. Next problem. So we can just check to see what we had here. You can see 36 is the answer at the end of that. Let's go on problem 3. A palindromic number reads the same from left to right as from right to left. Okay, so backwards and forwards, it reads the same. Such a number is called palindromic number. So 14541, read it backwards, 14541. I'll give you another example as well. Oh, actually, they say this particular one, 15,951, shows on the odometer of your car. All right? They're assuming that the reader has got a car, which need not be a good assumption. So you've got the odometer reads as 15951. You can see the palindromic number. Then the question is, how far must you travel before the next palindromic number? These things are called palindromes, right? So the next palindrome appears. Now, if it starts with 15,000, it must end in 51. It's a palindrome. But you can put any number here in the middle. It could be a palindrome. But this is 15,951. Right? If you're traveling this, the new number will have to be more than that. So you can't put any number here to make this thing into a palindrome, because you can put the numbers from 0 up to 9, and none of them will be greater, except 9, which will be the same. But they want the next palindromic number. So the next one should be starting with 6, 116, and it's palindrome. And the very first one would be 16,061, because they ask you what before the next palindrome. The one after that is 16, 161, 16, 262, and so on. This is the earliest. And the question is, how far must you travel to get to that number? All you have to do is to just subtract these two numbers, and you see that it has to be how far must you travel. They didn't say that these are kilometers, but anyway, we'll have to assume that the units are all kilometers. Okay, so you have to travel 110 kilometers before you reach the next palindromic number. Okay, then, yeah, you can see I've also got the answer, 110 at the bottom. Let's go to problem 4. Problem 4 says 14th of February, Valentine's Day, is a Sunday in 2021. So in 2021, the 14th of February was a Sunday. Now, they say, what are the last 2 digits of the first year after 2021 that the Valentine's Day will fall again on a Sunday? Okay, so you have to take each year, 2021, the next one in 2022, the same date will appear on a Monday, because every year the 365 days, and if you divide that by 7, you get 52 weeks plus 1 day. Right? If you had 364 days, then the next one would have been on a Sunday again, because that's a multiple of 7. See, the same day occurs after every 7 days. But because you got 1 extra day, the next one will be a Monday. Like that, you got 2023, that will be a Tuesday, 2024, that's a Wednesday. But you have to be careful, because 2024 has got 366 days. Right, so we are going up to 14th of February. The calendar will say that 14th of February is before, we are looking at 2024, before the 29th of February. So this is fine. You're not jumping a day from the 14th of February 2023 to the 14th of February 2024. So this will be a Wednesday. But here, when you go from 2024 to 2025, you will cross the 29th of February. So this time you will go, there'll be a remainder of 2 in this case. So it'll be Wednesday, Thursday, Friday. You jump 2 days, because it's got 366 days, the 2024. But you still haven't come to a Sunday, 2026. Okay, just 1 extra. And then 2027, this is a Saturday. And 2027 is a Sunday. So that's the answer to the question. What are the last 2 digits? On the first year after 2021, that it falls on a Sunday, you can see first time it falls on a Sunday is on 2027, and the last 2 digits are 27. So the answer to the question is 27. They simply wanted the last 2 digits. Okay, so that is the answer to question 4. And you can see at the end of this, I got the same answer. I'm just displaying it this so that in case you didn't understand it very carefully, you can read through the prepared solution. Let's get on to problem number 5. Problem number 5 seems to be a geometry problem. So I say a triangular corner of side length CD equals CE. Oh, there's a CD equals CE of 10 centimeters is cut from an equilateral triangle. Equilateral triangle ABC. So this large triangle is equilateral triangle, and this is isosceles here, and because the 2 sides are 10, which means that the angle is 60 degrees already, and this is isosceles, so this is also equilateral, because the other 2 angles add up to 120, and they are equal. So this is equal to that. So the 2 numbers which add up to 120 are both 60 again. So this is an equilateral triangle. So all the sides of this equilateral triangle are 10. Okay. Now, what's the question? So what is the perimeter of quadrilateral ADEB? So you got this quadrilateral here. Perimeter means if you add up all these, All right. So if you add up the four sides of the triangle, the question is, what will the answer be? And this is quite straightforward because this is 10, so this has to be 20. It's an original equilateral triangle. So this will be 20. Likewise, this is 20. So if you add up everything, 30 plus 50, 60, 80. And they don't say whether it's centimeters or anything. So you just say 80. Okay, so there could have been an easier solution than that. I can tell you an easy solution. You see, the perimeter is actually ADEB. All right. So it's the same as the perimeter of your triangle. The perimeter of the triangle is 90. Because you've got 30, 30, 90. But the triangle has got, in addition to this one here, which is in that quadrilateral is a trapezium actually. In that trapezium, you've got two extra 10s. And this 10 is included in your trapezium. So it's actually 90 minus 10. See, another way of looking at it is you look at, let's cut this out and place it here. So the perimeter we're looking for is that plus that. This is pushed here, plus that plus that. So it's 90. There's only one which is not counted. This one here. It comes all the way down here, starts here and finishes up. So that has been removed. So it's 90 minus 10, which is 80. That is another way of looking at the same problem. Okay. Okay, so as you can see, the answer is 80. Let's go on to problem number 6. How many 3-digit numbers would the digits this are divisible by 3? So you have to pick 3 digits from 2, 3, 7, and 9. And you just take 3 digits, but they must be divisible by 3. Now, divisibility by 3, right, means that the sum of the digits is a multiple of 3. Okay, so what we've got here is, if you take all the digits, 2 plus 3 plus 7 plus 9, add everything, you get 16, 21. Okay, that's already a multiple of 3. So you want to remove one of these digits, one or more, and you want it still to be a multiple of 3. Now this is already a multiple of 3, so the only way you can do this is you can remove 3, and you get 2, 7, 9. Now those 3 numbers, they add up to 18, and no matter which way you arrange them, you've got a number which is a multiple of 3. So all the arrangements are 279, 297. Starting with 7, you get 729, 792, and then 9. Starting with 9, you have 927, 972. So there are 6 numbers using these, or you can remove 9, in which case you're left with 237. And for the same reason, you will have 6 new numbers there, and all of which are divisible by 3 because here they're adding up to 18, here they're adding up to 12. So the answer is 6 plus 6. Okay, those are the only numbers which are divisible by 3. You have to remove either 3 or 9 to get a number which is a multiple of 3. Okay, so let's get on to the next question. All right, you can see here it says making 12 numbers altogether in the last line. So this answer is also gives you the same thing. Let's go on to problem 7. Problem 7 says, what is the difference between the two prime numbers that add up to 1? Add up to 1 less than the largest perfect cube less than 100. Let's try to make life a little complicated here. You've got the largest, first let's understand, the largest perfect cube, which is less than 100. The cubes are 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed. So hopefully you'll know what the cubes are. But the largest perfect cube, which is less than 100, is this one. The next cube is more than 100. So it's going to be add up to 1 less than 64. So the two prime numbers called P1 and P2, right? Between the two prime numbers, they add up to, the sum is 1 less than 64, which is 63. So they ask you which two prime numbers must you add. Actually, they asked what is the difference between those two prime numbers. But first, you have to know which two prime numbers must you add to get 63. Now, you think, well, I mean, there are lots of prime numbers. You've got 7 and, okay, 7 doesn't work. But if you try, actually, 7 doesn't work. If you try 11, the next one, 7 and 56. Okay, but this is not a prime. 11 and 52, this is not a prime. Now, it won't take you long to realize that you're always going to get an even number, right? So that all the primes are odd. So the sum of two odd numbers will always be an even number. So it looks as if this is wrong. There's no answer to this question because prime numbers being odd must sum to an even number, and you can't get 63. But there is a problem here. There is one prime number which is not odd. So this is wrong. Right? One of the two primes is even. To get the sum of two numbers being an odd number, one must be even, one must be odd, but they are prime numbers. Therefore, that number must be P1, must be 2. That's the only even prime number. So your numbers P1 and P2 are 2. One of them is 2. The other one is 61. Okay, that's fine because that's a prime number. So these are the two prime numbers in the question, but they want to know the difference. So you just subtract 61 minus 2. The answer is 59. The question is, what is the difference between these two prime numbers? It's quite a mouthful to read this thing, but if you read it slowly, you'll be able to understand it. Okay, so our answer is 59. And let's look at, yeah, you can see right at the end, the answer that is given is indeed 59. So we will stop there.